What does actual development look like when you join?
Phabricator is our internal code review tooling. Phabricator is well integrated with Sandcastle, which is our internal CI tooling, which is integrated with On Demand, which are our internal dev boxes, which is integrated with Landcastle, which is how code makes its way out to users. And sort of the thing goes from there. And then it doesn't just stop at code review, it's integration across the rest of the developer platform. For example, Meta built its own task system. And so tasks and pull requests could be very deeply integrated in a way that we just don't see out here.
One tool that I kind of experienced because of Phabricator was called Herald.
Herald, if I recall correctly, was the rules engine, which later got replaced by Butterflybot. And the idea of both of them was the same. It was be able to match events that might happen in the normal course of code review. I used to work on internal developer tools there. When we were deprecating APIs, you might go ahead and do something like create a Herald rule that would say something like, if a user calls this function or uses this API, post a comment letting them know, hey, this is deprecated. Also, the new syntax is this. And then as you got later and later into the rollout, you could start to do things instead like, hey, notify me if anyone's adding call sites of this API so that I can go ahead and go leave a comment saying, hey, no, we're really trying to deprecate this.
Meta is famous for its customer internal tooling. Devs at the company use the likes of Phabricator, Sandcastle, or Butterflybot. But what are these tools, and why did Meta not use a more standard stack to build software? We get answers from Tomas Reimers, who was previously at Meta working on developer tooling before co-founding Graphite, a developer productivity platform. Today we talk about what stack diffs are and how they became the de facto way devs at Meta work with pull requests. Why Meta moved to a monorepo, and why there seems to be an industry-wide trend in companies moving from polyrepos to monorepos. Why AI coding tools will make code reviews a lot more important, and more. If you're interested in how effective engineering teams work these days and approaches trending in this group, this episode is for you. If you enjoy the show, please subscribe to the podcast and consider leaving a rating. This greatly helps the show. And with this, let's jump in. Thomas, it's great to have you on the podcast.
Great to be here.
So before you started Graphite, you worked at Meta, and Meta is known for a lot of their in-house tooling. Can we talk about, when you joined, what was interesting tools that you didn't see at other companies before?
So funny. It's a great question too. And yes, certainly. When I joined, I was a new grad. So I had just graduated college. I joined Meta. I used a lot of the tooling. My frame of reference was personal projects. I used to do a lot of hackathons back in college and internships. And so I think when I joined Meta, a lot of it came in sort of eyes wide, sort of like, I was about to say eyes wide open, but I mean the opposite of that. I came in sort of just like blissfully unaware that this wasn't industry standard. When I left was when I had the bigger shock, because I think I had used tools like GitHub before. I'd used analytics tools before. I had left Meta after having really gotten sort of immersed in all of this wonderful tooling. And then when I had to start to do all of these same activities myself, I found myself reaching for tools that didn't exist and there weren't clear analogs for.
Yeah, it's usually the other way around, right? Usually people who work in industry at a startup or even at a larger company go to Meta. And unless you've been in Google, where it's all custom, it's just a shock, because I think most people imagine they must use GitHub or at least something similar. But what does actual development look like? When you joined, right? You went into boot camp, I assume. What did it look like to they didn't even push a pull request, but that's not what they call it, do they?
No, they call it a diff. Good trivia for it, by the way. I think that if I had to use one word to describe Meta's internal tooling, it would be integrated. Everything integrates with each other. And I tell this to people and they never really understand the extent of it. Meta builds its own internal calendar, right? So meeting room scheduling can be integrated in with the rest of the tooling. And that really sort of permeates the whole thing, right? Phabricator is our internal code review tooling. Phabricator is well integrated with Sandcastle, which is our internal CI tooling, which is integrated with On Demand, which are our internal dev boxes, which is integrated with Landcastle, which is how code makes its way out to users. And sort of the thing goes from there. And then it doesn't just stop at code review, it's integration across the rest of sort of the developer platform. For example, Meta built its own task system. And so tasks and pull requests could be very deeply integrated in a way that we just don't see out here.
What was Sandcastle?
So Sandcastle was the internal CI system. So out here, a lot of people use GitHub Actions, they use BuildKite, and Sandcastle was just our flavor of that. It allowed us to build versions of our apps and websites before we released. and went ahead and tested them for us.
And you mentioned this like integration. Like, when you say it, it sounds like it's just a word, but like in practice, what did it mean? You did mention that, for example, tasks, which is, I guess we can think of it as the Jira or Linear or whatever that is, that was integrated with the other stuff. And this was like 10 years ago, right? Or so.
Yeah, actually. I think integration here, I think one of the best examples I have of integration was actually a translation system. So at scale, internationalization becomes a real problem, right? You need to be able to include internationalization as product developers start to update the website, create new pages, etc. There's always this question or this tension that happens of, well, how do we know that the string that we're pushing has a translated equivalent? At Facebook, that could actually just be built into the code review tooling, right? And so the code review tooling can tell you something like, hey, this diff is using a string for which the translations don't exist. And because of that, you can't deploy it yet. Or what was more interesting to me was when you looked at a diff that had been merged, that had been landed, that was what we called it, you would see on that same page like, hey, this diff has been rolled out to employees. This diff has been rolled out to 1% of users. This diff has been rolled out to 10% of users. Also, if this diff included any feature flags or sort of like A/B tests, here are the results of those A/B tests. And so you had this wonderful ecosystem where everything was tightly tied together. And so you as a developer could just go to one place and be like, I know what I'm looking for. I'm looking for this piece of like code that I landed. Let's go see like how it's changed statistics or how it's impacted users. And you could see that all in one place. And then there was a bunch of other stuff that started to make its way into the public toolchain now of if you wanted to revert a diff, you could just go ahead and do that directly from Phabricator.
This episode is brought to you by Swarmia, the engineering intelligence platform for modern software organizations. Swarmia gives everyone in your organization the visibility and tools they need to get better at getting better. Engineering leaders use Swarmia to balance the investment between different types of work, stay on top of cross-team initiatives, and automate the creation of cost capitalization reports. Engineering managers and team leads get access to a powerful combination of research-backed engineering metrics and developer experience surveys to identify and eliminate process bottlenecks. Software engineers speed up their daily workflows with Swarmia's two-way Slack notifications, working agreements, and team-focused insights. You can learn more about how some of the world's best software organizations, including Miro, Docker, and Webflow, use Swarmia to build better software faster at swarmia.com/pragmatic. That is swarmia.com/pragmatic. Phabricator was a really central part of this. I know because at Uber, we use Phabricator. It was an open source tooling, and I think Uber, and you mentioned Dropbox, also took it on. Maybe a few other companies, but not as many. So for a while, we kind of used it. I saw some of this integration, but it sounds a little wild because I don't really know any other company, maybe outside of Google, where you can have this thing that, as you say, you deploy a code and you can see the experiments, the localization, the rollout, all from one UI. Usually it's different systems. Even at Uber, it was different systems. We had like an experimentation system. It was called Morpheus at the time, or Flipper, the feature flags. It was, and we had, I had this list of like systems that I, like a cheat sheet of where I would go to check the rollout, the internationalization, et cetera, et cetera, et cetera. So all of this was really kind of like one click away.
I think that's the way it exists for a lot of people today. I think when we look of right now, best in class dev tooling is starting to become more integrated. I think around like Linear, it's now starting to post the Linear issue in the GitHub pull request, and you can see, and it updates the status as the pull request moves through review. You're also seeing the same with Vercel, right? When you create a PR, Vercel can go ahead and be like, hey, went ahead and like made a preview environment for you. You can go ahead and click that there. I think what was so magical about Facebook is that all of that was native, and it didn't appear to be integrations, but just part of the system.
And who built this tool, right? Like the developer tooling, Phabricator, the Sandcastle, all of these things. Was it just like devs like, okay, I'm going to build this? Obviously it was internal teams, right? But was it like dedicated teams or people just kind of went and tweaked stuff?
I think it really depends on the tool. Some internal dev tools were just built by developers themselves. They saw a problem. They're like, nothing's addressing this. I need to fix it.
That's
Some
awesome.
came more from the isn't it? It's a wonderful culture to be a part of where you can solve your own problems. But some of it came more from the like, oh, we as a company have noticed that there's an issue here. We need to address the issue. Let's spin up a team to do it. And then the place where all of these teams or all of these tools ultimately found their home was under the dev infrastructure team. So developer infrastructure at other companies called developer platform or developer velocity really maintained the bulk of Facebook's developer tooling.
Yeah, and I guess like one tool that I kind of experienced because of Phabricator was called Herald. I'm not sure if you know. So it was
of course.
You could set up special rules on the code base, anything. Like if basically on a commit, anything happens, like weird rules could run. Were there like, can you like, do you remember some like there were some really creative examples of like using Herald rules for developers to start to create their own rules or code ownership or that kind of stuff?
Totally. So Herald, if I recall correctly, was the rules engine, which later got replaced by Butterflybot.
Yeah.
And the idea of both of them was the same. It was be able to match events that might happen in the normal course of code review. Something like someone puts up a PR that includes some line of code or calls some function or CI fails regarding something. And then what it would do is it could take a variety of actions. So some of the examples that I remember was when I used to work on internal developer tools there. When we were deprecating APIs, you might go ahead and do something like create a Herald rule that would say something like, if a user calls this function or uses this API, like post a comment letting them know, hey, this is deprecated. Also, the new syntax is this. And then as you got later and later into the rollout, you could start to do things instead like, hey, notify me if anyone's adding call sets of this API so that I can go ahead and go leave a comment saying, hey, like, no, we're really trying to deprecate this. Like, please stop. And then you could take it from there. Other examples were simpler. I remember there were some cases where there were, let's call it privileged or important parts of the code base. And what you'd say is like, if someone goes ahead and creates code that touches that part of the code base, just make sure this team is added as a reviewer or at very least as a subscriber. Subscribers were an idea in Phabricator of being able to CC people. It wasn't that you expected a review, more just that you wanted to keep their eyes on it. And there were a handful of rules like that.
And do I remember correctly that code ownership was super, super important for Phabricator and for Facebook? And it was just really trivial to say, I own parts of the code and then set up different rules around that?
No, so that's a great question. So code ownership actually became, code ownership went through a few stages at Facebook. There was a while where code owners were required at Facebook. And so you could have like different parts of the code base could have different owners. Then the company took it away. And they said, actually, we don't believe that we should have code owners. We're a collaborative environment. We should go ahead and get rid of that. It was then reintroduced. And I think it was then again taken away.
Wow.
With the idea of like, we're not sure. The company alternated between, they're really privileged parts of our monorepo. And we can talk more around sort of how Facebook structured their code that need certain people to review it. And well, actually, we should trust our developers. Developers need to be able to understand organizational practice. One thing that was always existing within the platform, though, was this idea of if you're in some part of the code base, tag the correct reviewers. And so I think one of the things that actually I most missed when I got out here was the ability to structure a repository in a way where you could say, if you touch this part of it, we should tag these people in. I think in GitHub, code owners is a very coarse approximation of that, where you have to define one file. It's at the root of the repository. It's difficult to use. A person who I've heard has done this even better, a company, is Google. So in Google, code reviewers were assigned hierarchically. And so in every folder, you could basically say like, hey, if you touch code in this folder, like you need to go talk to these people, either as a heads up or as a requirement. And it allowed people to get, there were two really nice aspects of that. One was that it was really easy to define ownership. And then the second was that it was easy as you were writing pull requests there to be able to go ahead and say like, who does own this code? Who can I go ask for? And so if you're say that you were using an API that you weren't certain of, you need to figure out like, who can I go talk to about this API? What you could do is you could just navigate the file tree, find the team or people in charge of it, and then just go DM them. And so that became a really powerful system there.
Now, you've gone back and forth between, at Facebook, there was code owners, no code owners, and you're now working at a startup. You actually work with a lot of startups and larger companies. What is your kind of unfiltered view on code ownership? Is it a good thing? Is it a bad thing? Is it necessary only when you're bigger or when you're smaller? I'm sure you've got some opinions now.
I work at a startup now, Graphite. We have the privilege of working with some of the largest DevTools teams in the world, which is really cool. At this point, I think I've heard all sides of the story. I've heard we are in a financially regulated market, and because of that, we have a legal requirement to have code owners. And so I've heard that side of the world. I've also heard the side of the world of, oh, we couldn't possibly do code owners here. Like it would just slow us down too much. And so I think it really depends on the nature of the business. I once saw this matrix, which I really liked, which is if you trust people a lot and are willing to tolerate like small mistakes, you should lean on culture, not process. As you start to get into a place of, actually, maybe I trust the people less, or I can't tolerate mistakes at all, you move to automation and enforcement. And so it really depends sort of where your business falls on that. I also will say that I think that as Facebook's grown, the way they treat different parts of their code base has changed. Where some parts of the code base absolutely cannot go down, right? Things that deal with privacy cannot go down. That's not a place where you can move fast. Some other things, perhaps, maybe the way that you display comments, if it's not a big deal, that actually is a little bit easier, or a new product even. There you have a little bit more leeway to move quickly, and so maybe code owners isn't the right match.
Yeah, and one thing that I've kind of like learned over time is maybe inside a company, as much as you'd like to think that there's one engineering culture, maybe that's not the answer. Maybe like a new startup inside a company, like an established company like Meta, a new startup, maybe it should operate differently, because maybe they'll be shut down in 6 months if they don't find product market fit, and they should just throw away the things. It's a little bit at the same time. I think companies don't really like to admit it, but like and maybe even inside a small company, right? Like if you start just a small prototype project, see if it goes anywhere, you're probably not going to have the same rigid thing as when you're deploying to, like customers who actually count on it. It needs to stay up.
I think that's a really wise point. I think that ultimately engineering anywhere exists within a system of constraints. And I think those constraints within a company can be very different. And so recognizing what are the constraints on the product I'm building right now and architecting your systems around it is an engineering problem like any other, right? Sometimes you have constraints of, I think the place where this actually comes to me most clearly is when I deal with developer tools teams who release mobile apps versus web apps. So web apps tend to release on a hourly basis, maybe multiple times a day, but probably not slower than that. Whereas mobile apps release on a weekly cadence. Because of that, just the shape of problems they deal with are so different, even within a company. So mobile app teams generally don't have to hold pagers, because even if something goes down, what are you going to do? Submit a fix to Apple? Great, that's 2 days. Yeah. Versus a web app team, like paging is an important part of the culture, right? As you're shipping things really quickly, things will break, things will go down, and you're on the hook to fix them. And so watching the difference between those cultures, I think is probably the two extremes you see within a company. And then again, as you start to work in different parts, if you work on payment processing versus abuse and fraud detection versus the consumer front end versus authentication, you actually have different constraints, which are subtly different. And I think that, as you're saying, engineering organizations can develop different cultures around how they need to treat them.
I like this thinking of constraints and how, it leads to different practices. Now, one thing that really surprised me at Uber, which came really from Meta, from Phabricator, is we use this thing called stack diffs. And we did a deep dive into Pragmatic Engineer. It'll be linked in the notes below, but it's something that it just really clicked for me, and also everyone around me, everyone I talk with at Meta. You've now actually built a business on top of this. But can we talk about what is stack diffs, and how did you come across it, and why is it so useful once you get a hang of it?
Absolutely. So you're right. We've spent a lot of time talking to people about stack diffs, and stack PRs as they're called on GitHub. And I think that we've had a lot of practice about how to talk about it. I think the way I like to introduce stacking is by talking around the problem that it solves. And the problem that it solves is, in any given engineering organization, you have a bunch of engineers who at any given moment might tell you they're blocked. They're blocked on code review. And I think when you really sort of start to ask, well, why are they blocked? Why is code review blocking them? What it comes down to is, in most engineering organizations, the way development works is you have a main line. So you have a main branch or a master branch. You go ahead, you fork off of that. Yep. You go ahead and you create your feature branch. And then you kind of get stuck, because before you can continue to develop on top of that feature branch, it needs to merge back into main.
It back. Yep.
Because exactly. You need to merge it back because you only create feature branches off of main. The downside of that, though, is that your personal development process now becomes blocked on review because you've created some PR, you've created the perfect way to do, authentication, login, and you now want to build forgot password. And so your options here are you can either add forgot password back into that branch, but suddenly that branch is going to become really big and your reviewer's not going to be able to review it. Or if they review it, they're going to give it a rubber stamp, looks good to me.
Yeah. That kind of, there's no point in a code review when you do that.
Exactly. And so Google has a funny academic paper where they refer to it as reviewer frustration. As pull requests get longer, reviewers buy out of the process and end up just approving things rather than actually reading them. And so the solution which Meta stumbled upon is what they called stacking. Google, I've heard, has stumbled on something similar. There might be some cross-pollination with Meta there. But the idea is you create your feature branch, you put it up for review, and rather than waiting for it to be reviewed for you to start building, you just branch off of that and keep going. And you create another feature branch, and then you put that up for review. And then while you wait for that to be reviewed, you create another feature branch and you create that to be reviewed. Now, people who have been using Git long enough, most of them have tried something like this. And I think inevitably you end up with a few questions. One is, well, what if someone rightly calls out that earlier PR needs to be updated? The general answer is that's actually fine. Generally, when you need to update a PR, you're not changing the abstraction boundary between PRs. An example of how you might break it out is if you're building a new feature, I have server and then I have front end. And so even if someone's like, hey, can we refactor this server? Usually the endpoint abstraction is actually staying in place. And so the next PR can continue to be stacked on top of it. The other question is, how do I know what I'm supposed to break up? And I think for that, generally, and this is actually really interesting to me, generally developers build their systems in order, right? You might start building the server and then building the front end. I think stacking is just a way to communicate that same order to your reviewers. A lot of people do this automatically using commits, right? They just say I'm going to build commits in the order I would build them, and you should review them by commits. Stacking goes a step further and says, well, if the first 3 commits in our branch are approved, why not merge those while you wait for the latter ones to be approved? Yeah. And that has a few other benefits. You can run CI on them separately. You can reduce merge conflicts, and you tend to be able to reduce your time to merge, because if there are sticky things, you get stuck there, but can still merge a lot of other code. The other advantages then happen sort of afterwards of, in the case that there's an error or something like that, you can go ahead, quickly identify which PR was offending. And if you tell me a 10-line PR is offending as opposed to a 2,000-line PR, it's much easier for me to identify the issue.
So basically, you get to work in just smaller increments. It's almost like forking off of your current branch, smaller and small, have a bunch of small forks, except it's just a tooling, right? So why do people not do this? Just forget about the tooling that Meta have, but you could just literally, create a branch and then create yet another branch. But I guess it's just really complex to look at what's happening, complex to merge it back.
I think Git makes it scary, and I think GitHub makes it scary. So in Git, the most basic way to do this would be to create branches off of branches. But then if you need to update something, you need to go ahead and rebase it. Now, that's where I just use a really scary word for a lot of people, rebase.
Rebase.
Right?
Oh, we hate rebasing. I mean, okay, I can't talk for anyone, but I'm going to admit it always freaked me. Having the rebase conflict and figuring out what I need to do,
It scares me, and I've been doing this for years. I actually have a Stack Overflow post bookmark, which is the 3 types of rebase, because depending on how many arguments you give it, it behaves differently. And so super frightening. I think that's the place. I'm very fortunate that I learned this at Meta, because I think what Meta has and what I've learned Google has and what I've learned places like Stripe and Uber have built are internal tools to handle this for you, where you can basically say I'm creating a stack now. I now need to update a branch in my stack. Do that for me. And under the hood, it takes care of this intricate set of rebases that, while you can do by hand, are easy to mess up. Now, there's a lot of tooling that does that client side portion. The other half of this is the pull request side. Is if your host wherever you have your pull request does not have support for stacking, I think stacks can look very foreign, because what you end up looking with is a lot of PRs that appear to be merging into that appear to be recursively merging into different branches that they were all based off of. And so it can be hard to understand what's going on. And without any clear explanation or affordance in the UI, your reviewer might become confused too.
So I'm kind of like wondering if you have a theory, why did, like a few companies like Meta and Google invent this? And why is it just not part of Git or GitHub? I'm sure you speculated about this. You must have.
Certainly. So why I think some companies built this? I think first and foremost, the current tools weren't solving their own needs. Right?
Current tools being Git and GitHub-like and
Git or whatever they had at the time, right?
Yeah.
At
Mercurial.
Meta, it was
at
Mercurial.
Meta.
Yep. I think they were shipping a high volume. I think they were really early on monorepos. And I think that they were getting to this point where, okay, I'm blocked on review. Progressively larger parts of this org are blocked on review. And as you sort of like start to grow up as a company, you realize like, if developers are spending 20% of their time waiting, that's actually a lot of inefficiency that's being created across the org, right? Most people that run an org of over 100 engineers would be like, I would love to have 20 more engineers. Second thing is that they saw the potential impact. So I think for a lot of people, they sort of like saw that lift of like, okay, Facebook, for example, really prioritized being able to improve their ship velocity for whatever reason. It mattered to them a lot.
Yeah.
Google, I think, did as well we're a web company. If we can like continuously deploy, we can continue to improve things. And thirdly, I think they had near infinite resources. And this is the thing that I think most of us don't have, which is they saw the potential impact, they saw a problem, they had the resources, and so they could build a solution. I think it's much harder when you're a startup or even just a smaller scale company than one of the three most valuable companies in the world to be able to say like, I'm going to take a few engineers and I'm going to build this.
Yeah, I mean,
so
these are companies who are printing money despite having thousands of engineers, even tens of thousands. So they, I mean,
exactly.
Obviously they're going to like be rational. They're not just going to create a team out of thin air. But this is very interesting because what you mentioned is I remember I talked with Nicole, with Nicole Forsgren about developer productivity, and one of the things that came up when we discussed is like, well, you do want to like measure certain things just to get a sense, and one of them is typically code review, like how long does it take from writing the code to getting it in there. So I have a feeling that companies like Meta, Google, and some of these bigger ones who did have the resources, they start to measure it earlier. Therefore, they decided, let's build better tooling. And one interesting part that I've only learned recently, I was talking with one of the three Linux fellows, Greg. He's, and he told me something interesting, that Git was created by the Linux community, well, specifically Linux servers, but it was to solve their issue of Linux development, where they had about 3 to 4 changes per hour or so, and it was an email-based list. So they created Git to solve their own problem. And now I think they have something like 40, 50 changes per day or per hour, something like that. I think it's per day, actually. That's their rate. And they built it. It solved for them. They open sourced it, but it was for them. There's this Linux. There's this big, it's also a monolith. The changes are pretty small for the most part. There's not as much, let's say, like user-facing code, etc. But they solve for themselves. So I wonder if they just didn't really have the problem that StackDiff does, because they don't have. If you look at the average Linux change, it's a lot smaller than, let's say, like a new feature being added to some of the code bases at like Meta or Uber.
I think you hit the nail on the head with it's really important to use tools that are built for your use case. I think that open source development generally, and Linux specifically, stacking makes no sense for. So people always ask me sort of like, who is stacking not for? My answer is open source. And the reasoning is that in open source, you're dealing with a lot of untrusted authors who come to you. They're like, hey, I have this feature. It's partially built. I don't have tests for it yet. I haven't fully tested it. Can I merge it? And it's funny in that in a company, if you're like, I have this feature, it's partially built. Hell, maybe you even have some tests for it, but the feature's not totally there. You're like, I know you're going to be here tomorrow, right? And so, cool. Thank you for doing your job. I appreciate that you're contributing back to the code base and that you're going to prevent me from having to resolve rebase conflicts later or merge conflicts. I think that in Linux, you kind of see the opposite, right? And if you've ever spent time on those email lists, you'll see people throw back and forth sort of like patches. And what will happen is that they'll say like, oh, like, this isn't complete. You're not going to work on this edge case, right?
Yeah.
And rather than saying like, you know what, like we can put this behind a feature flag and merge it, they're instead like, go take this back, fix it, fully finish it, wrap it in tests and documentation and everything else, and only then can you merge it. And that makes a ton of sense in open source, right? Having worked on open source repos myself, the biggest fear is that the contributor is just going to disappear.
Yeah.
It happens more often than we like to admit. They get busy, something happens. And so in that case, you don't want to land partial stacks. You want to make sure that the thing is fully complete before you even consider like reviewing it, truthfully.
Yeah, and this is actually like when I had a discussion, this trust came up so much with open source. So it's interesting how, like, you know, as you said, the context, like inside a company where you have people, you can actually trust them that they'll follow up, or if they don't follow up, it's not a big deal. You know, like it might be deleted. Interesting how this context like makes such a big difference. Now, another thing that is unique, I guess, maybe not just to large companies, but it kind of started there, monorepos. Yeah. So what was the, you know, Meta and Google were probably one of the two companies to start doing monorepos. You've seen it at Meta. What was the history with the monorepo story there, and the kind of pain points you saw? Yeah,
totally. I think you have to remember, so first things first, you have to remember that source control at Meta has a funny history. When that company started, and this is well before my time, rumor has it the way they did source control is emailing back and forth zip files. And so at some point they started, I mean, that wasn't so uncommon, right? Git itself is a fairly new innovation, came around in 2007, 2008. And so I think that when Facebook started to do source control, they had this idea that, well, we want to be able to version everything together. And I think there are a lot of advantages to that. I think one is it makes collaboration a lot easier. It makes discovery a lot easier. I think it makes it easy to put dependencies between different services. So I think all of us have had that case where it's like, oh, well, I need to change this, but that also means I need to change the call sites, or that also means I need to change this other thing. Monorepos allow you to do that, right? Because what it's saying is there's one like unified state of the world that we can look at, can make sense, and everything's good. We can test against even. Polyrepos, the opposite of that, when an organization has many repositories, I think have different advantages. You can version them separately. You can have different practices within them. You can have entirely different owners within them. I actually think that GitHub on many companies pushes a culture of polyrepos because it's what's open. It's what's common in open source, right? So again, going back to this narrative of sort of like, oh, open source is different than closed source. I think in open source, you actually want things like, I don't want to have to version at the same time that all of my dependencies are versioning on. That doesn't make sense. Yeah. I'm not really collaborating with my dependencies. Yes, I depend on other open source projects, but perhaps I'm not contributing to them. I think within a company, those constraints change, right? Within a company, you're looking at constraints of like, I want to collaborate with other people. I want to be able to version things. And so you get pushed towards sort of like one unified source of truth for like, what is the state of our code base? Now, by the time I was there, Facebook wasn't even one monorepo. It was multiple monorepos. I remember hearing someone refer to it as a polylith, which made me laugh a lot, where there was the main web monorepo. Yeah. There was Instagram, which was separate. There were the mobile apps, which were separate than that. There was internal tooling, which was completely separate. And they were on a mission to try and unify these into all of them into one massive monorepo, because the negatives of not having one monorepo were starting to affect the company. Some examples of that might be that if you wanted to do an end-to-end test on mobile apps, I remember there was some test that would pull down a copy of the other repository, spin up a server from that repository, and then spin up the mobile app such that they could test against that. And that led to all sorts of conflicts, right? Like it makes your CI flakier. It makes it hard to version against. When we had dependencies between repositories, that was a nightmare. And so by bringing everything under one roof, it allowed you to really collaborate across the company more actively, and it allowed you to share dependencies. So like Facebook was being slowed down despite having, you know, a few mega repos, if you will, or these large ones. So they saw this advantage. In the end, did they move to one unified monorepo between iOS, Android, and even web? When I was leaving, they were on the journey to. Wow! I remember hearing recently that they're still on the journey to. That's really, it's such a different code, especially for native mobile. But yeah. But the advantage of it, though, and again, going back to it, is I think that it allows you to enforce a common set of eng practices and requirements, right? Like the idea of like, oh, every repository should have at least one reviewer, right? In a company, yeah, that probably is a company-wide requirement. But in open source, like I can't be guaranteed that every open source project wants the same set of requirements.
And it's interesting because it's not just Meta. Like other companies, when they grow a certain size, they start to have the same journey. I've seen it at Uber. As far as I understand, Shopify is doing similar things. I assume that as companies go larger, they'll have these typically starts with like, oh, what about a vulnerability of a library being updated? Would it not be nice if it was in one place? Now, you've seen more of these through with Graphite when you're interrogating with some of these companies. Do you see some trends of like when monorepos are starting to become important, and if they are starting to become more important, why do you think we're not seeing GitHub support too much of this still?
It's a great question. So first and foremost, I think that we're watching an industry-wide move towards monorepos. Most companies we're talking to are already in a monorepo or are migrating to a monorepo.
Really?
At least for the people that we talk with in Silicon Valley, a lot of people have decided, this is actually the future. I see the advantage. The tooling's there. Someone should be moving here. And so we're actually seeing a broader sort of like trend towards monorepos. Why do I not think GitHub supports it? I think it doesn't make sense for open source. I think we're just starting to see the advent of monorepos in open source. I think React is closer to a monorepo than not. I think that Vercel follows the same pattern, probably a lot of the same energy there. I think we're seeing a lot of repos say like, well, maybe multiple packages should be in one repo. But there are a lot of advantages to being able to put them all together. But I still think it's not the norm. Right? When you look at like the JavaScript ecosystem or the Rust ecosystem or the Python ecosystem, we still live in a world of many separate packages from many different authors with many different cultures. Yeah. And the way that you want to manage those is through polyrepos.
Yeah. And then when you say, you see a lot of companies can you just get a sense of what types of companies in terms of the size, the funding stage? Like I appreciate you might not be able to say specific names here who do not advertise it, but it was pretty surprising for me to say that a lot of the companies you work with.
A lot of them are moving. No, I'd say that Graphite tends to work with with Silicon Valley based companies that are somewhere between, call it like 100 and high thousands of people, maybe 10,000 people. And so for us, I think it's a lot of the forward thinkers who are really investing in developer velocity, as you were talking about earlier, that are starting to invest in the like, how do I speed up my team, are very quickly realizing that the coordination overhead of polyrepos makes it harder to speed up your team. It both slows your team down in code review in weird, insidious and second order effect ways. And it makes it hard to enforce a common culture, right? So when we talk to DevTools teams and they're like, oh, we want to migrate CI. When you're in a monorepo, that is a somewhat straightforward operation. When you're in a polyrepo, that is a multi-year journey that you're on.
Oh yeah. And yeah. I think I can emphasize with this. Yeah, and I think what you said, like it needs to be some investment. Like it doesn't just happen like this. There's better tools now, but you need to have like dedicated people looking at vendors who are doing it, etc. So probably makes sense that the teams who are investing in better tooling are probably the ones who are looking at these alternatives. Now,
and that there's probably some selection effect in who we talk to, right? Of when teams want to invest in tooling, they start talking to us, and at that point, they've already started to consider the monorepo journey.
Well, I mean, you don't need to tell me because I've seen the benefits of monorepo. I mean, I see the costs as well, but it was so good at Uber, so many benefits, and like I would, if I had a magic wand, I would say let's do monorepo. Obviously, there's a cost, so I see this. I'm just surprised that it's kind of an encouraging way that there's so much of this happening.
I think another place where things got confused, let's call it, is that people associate microservices with many repos. Yes. And I think, again, that's because that's a way that I think GitHub very much encourages you to think of like, oh, you have abstractions between code, you should have different repos. And I think that I have a friend, also from Facebook, who likes to joke that the discovery of monorepos is really just the discovery of folder structure, where it's like, well, yeah, so you have multiple different pieces of code, but you can just put them in different folders. That's okay. And then
I think probably one of the best examples. Uber is known for advertising how they have 5,000 plus microservices, and they do have monorepos. I think per language, like 4 or 5. But yes, you can. It's not dependent. It's totally independent from one another.
Exactly right.
Now, one other trend that's happening now everywhere, especially with the forward-thinking companies, is AI tools for code generation or for coding. How do you see this changing how code is written, both through the companies that you work at or maybe even at Graphite?
It's incredible. It's been a whole conversation at Graphite, and it's definitely been a whole conversation with a lot of the companies we work with. I think the most immediate impact of how will AI impact software engineering is there will be more software written, right? There is going to be more code written as the tools make it easier and easier for developers to ship code. I think what's not as obvious is the second order effect, right? If you have more code written, well, what needs to happen? Well, more code needs to be reviewed. And if more code's reviewed, more code needs to be tested, and more code needs to be merged, and more code needs to be deployed. And I think that's suddenly the place where we're seeing people run into issues where they say, okay, I think that we're ready to adopt one of these AI tools that helps us generate code, that helps our developers code faster. Let's do that. And then what immediately happens is we see the volume of pull requests go up. We see the size of those pull requests go up. We see the amount of bugs or CI bills also go up. And I think getting ready for that transformation is a thing that the industry is just starting to grapple with.
This episode was brought to you by Sentry. Buggy lines of code and long API calls are impossible to debug, and random app crashes are things no software engineer is a fan of. This is why over 4 million developers use Sentry to fix errors and crashes and solve hidden or tricky performance issues. Sentry cuts debugging time in half. No more soul-crushing log sifting or vague user reports like, "It broke, fix it." Get the context you need to know what happened, when it happened, and the impact, down to the device, browser, and even a replay of what the user did before the error. Sentry will alert the right dev on your team with the exact broken line of code so they can push a fix fast, or let AutoFix handle the repetitive fixes so your team can focus on the real problems. Sentry helped Monday.com reduce their errors by 60% and sped up time to resolution for Nextdoor by 45 minutes per dev per issue. Get your whole team on Sentry in seconds by heading to sentry.io/pragmatic. That is sentry.io/pragmatic. Or use the code pragmatic on sign up for 3 months on the team plan and 50,000 errors per month for free. Now, this is speculative, but it's good to speculate sometimes. How do you think successful companies will cope with it? And this is, we can just speculate, right? Like, we know there's going to be more code being churned out. Devs will be able to generate stuff faster, build features faster. And yes, it will have all these, a lot of them will just tap, except they're going to not notice certain things being there. We'll even have like attacks of some companies trying to have malicious, a bit like, Stack Overflow, copy paste, and you have the memory leak. We'll have more of those. Let's just do the thought experiment. Like, how will good teams deal with this?
I think AI necessarily is both the problem and the solution. So I think that the fastest moving teams are going to adopt AI. I think we've moved past the world where you can say like, this is a fad, this will pass. AI is going to mean a lasting change on the software development industry, period. I think that you're right. It's going to create some problems, right? You have developers just clicking tab nonstop, probably importing code that they neither read nor reviewed. Well, we already have it, right?
It's called vibe coding.
Yeah. I love the Twitter memes about it. But yeah, vibe coding's a thing, right? You have developers at your company who are probably just talking to their computer, telling it like, yeah, create this website. No, I'm not going to read that code. And they're putting it up for code review. And I think that, to me, that just emphasizes the point of code review, because if the author didn't read the code, then someone else certainly should. And the question is, how are we going to make sure that happens? And so I have 2 answers for you. One is, I think a lot of the practices that already existed at these major companies, at the Google and Facebook, and to a lesser extent, but still an extent, Uber, Twitter, Snapchat, which are used to seeing a high volume of changes written by a diverse employee pool. A a lot of those practices are going to percolate down, because those used to be the problems of like, well, you only run into this issue if you have 100 developers. We see it on Twitter. People are saying teams of 10 can start acting like teams of 100 developers. And so that also comes with the problems of hundreds of developers. The second solution is I think that AI is going to transform the way that we view code review. I think the largest change which has happened, something which we are trying to keep up with internally, is that I think we're seeing the same advent that happened when something like Grammarly or the grammar checker in Word happened, where AI can actually check a lot of the minutia or mechanics of code review. It can tell you that like, yes, this code works, or yes, this code does what it intended to do. The question though of code review then isn't, is this code literally bug free? It's, is this aligned with what we wanted it to do, right? Is this, we spec'd out the system, it was supposed to work this way, or maybe we have built the system and it does work this way. What are the other effects of that? How does this interplay with everything else we do at this company? What's going to happen there? And I think that we're going to see AI tools built. We're building one ourselves, our AI reviewer, that let developers automatically check this code for sort of like the simple stuff, allowing the reviewers to focus on the more complicated stuff.
Do you think testing will become more important in this world where we do have like a lot more AI tools, a lot more AI code, a lot more, pushing to production?
I think testing is going to change. And so is it going to become more important? Probably. In some form, definitely. Because as I said, I think that if developers are not putting thought into every keystroke, but instead we're just seeing like this code written quickly, checking that code for correctness, both the like literal, like does the function work as intended, and the end-to-end correctness of like, are the buttons in the right place and is it usable, are critical. Now, I think what's really interesting, or the trend that we're seeing, is that it appears that AI can actually write tests for you in some limited cases. And when we look at some of the more advanced AI agents, they actually do this as part of their coding, right? If you ask an agent to like generate a change and also test it, it'll do a pretty good job. And I think that a lot of the previous types of tests that before were restricted to QA people or to humans, of like, look at this website and try to like click around it with the mouse, where before we had to use an end-to-end testing tool. It was hard. We'd kind of be like, oh, go click at like XY location this. You can now give it to like
at Uber,
computer
we
use.
even hired, like testers who we call this sanity testing. You describe what to do, go there, take a credit card. And like, that was because I was on payments team. Like we actually had some of the fake credit cards that were take one of them, enter it there. And we did it because we couldn't really automate it for different reasons. The payments is a bit tricky, but it was.
Facebook was exactly the same.
Terrible job to do, but someone had to do it, and someone was being paid. So
exactly, and it's. I think that again, the machines can start to do a lot of this work. I think the question that we have to grapple with then is: so, what is the purpose of this review step, right? Mm-hmm. Why? And I think that for a lot of people, this is a question we used to talk about like 3 years ago. And I think with time, with the advantage of time, we've had a lot more clarity of like, the purpose of code review isn't just the mechanical. It's not just, hey, can you proofread my essay for me because I want to make sure there are no grammar mistakes in it. I think there's also a type of shared learning that happens of, hey, I want other people to code review this because I want to distribute my knowledge of how the system works. And I think that there's an alignment checking that happens of, hey, there's this is how we build software here, and there's tribal knowledge that maybe more senior staff level engineers at your company have that they disseminate through the process of code review. And I think that as we take away these mechanical parts or reduce their need, you're going to see those latter two become a lot more emphasized.
I am a little worried, though, about we do see that AI tools are very capable of generating code. And I think, like experienced developers who've been in the industry for 10 plus years, and I've seen, for example, they work with the teams of junior engineers, and you see what happens, it's a bit of a mess, then you need to really clean it up. Like I think, they see that this has limitations, right? Like it's a very powerful tool when you know what good output is, when you can check it, when you can step in and say, this is BS, stop, or you just stop prompting after a while because it's not going anywhere, and you take over and you just write whatever you need to do. But I do feel that people over-index on how good it generates code. And I have a feeling that a lot of companies or especially, like company leaders, even CTOs, they'll kind of ignore this part of learning because it's invisible, right? Like you don't really see the difference between like two teams. One, there's no code review or just AI code review. Everyone's doing their own thing, and and they're both shipping for a while. And at some point, something breaks. And this team, where people are actually doing code reviews, they're thoughtful, they understand the code. They can start. Nothing slows down. They build the new features. They innovate. Whereas this one kind of gets stuck. There's just bugs. No one knows why. But because it's not visible, like I have this feeling that there might be. I don't want to be all negative about it, but it's just so many steps removed from the work that I wonder if few companies will appreciate it. A bit like how few companies used to appreciate developer tools. It's only fashionable these days, right? Like if you think about it, 10 or 15 years ago, everyone was looking why is Google having a dedicated team to build internal dev tools? That's weird.
I think it became popular with, I'll give a lot of credit to Heroku. I think I remember just growing up in that era, there was a lot of love for this is what good can look like, and I think it really set a standard of we don't have to accept worse. We can have better tooling sort of in the popular opinion. And then a lot of Heroku developers went on to go to companies, brought a lot of that energy and feeling with them. And then we started to see it seated there. But yeah, I remember when Google, there was a lot of sort of question marks around what is Google doing? Why would you invest so much in this? And Meta too. I think that where this will be different with AI is the fact that at the end of the day, code has really profound business decisions, right?
True.
If you decide that you want to give a refund or you want to charge this or the user experience wants to look like this or this is the way the product works, that's at the end of the day a business decision. And I think that what leaders will agree with is that they don't want the machines making business decisions. Yeah. And so at that point, at some level, that means that a human needs to be reviewing it. And now the question is sort of what is that level and what is that granularity that we review on? I think that we can find a common understanding and okay, humans will need to at least check for intent the same way humans prompt. And that's not to say that prompting's bad or it doesn't work. It's more that just, I think fundamentally human natural language communication is flawed, right?
Yeah.
You and I have a conversation and you can understand something different than what I mean. And at a company, the way we get around this is we then check on the other side, right? We align at the start and we check at the end. And I don't think that's going to go away. Yeah,
I like this thinking. And also, I wonder if we might have more companies discover, again, I'm just a little bit inspired by Linux, as I recently talked with Greg from there, that the way Linux works, when I talked about how the whole project works, I was really surprised in how much it's about people. And the core concept there is when you take a patch, they call a PR a patch there, you now own it and you are personally responsible for it. And this actually, if something goes, and this is how there's a pyramid of subsystem owners, system owners, and then in the end there's Linus Torvalds. So every single release for Linux, it goes through. It's still to this day, it goes through him. He owns it, and he's very happy to take that responsibility. But Greg was telling me that because of this, if you think about it, and it's very open, the whole world sees your changes. So because of this, people take pride in this. They will both review, but there's also trust levels, right? So if you're a system owner and there's a subsystem owner, you've worked now for 10 years, this person is solid, you're not gonna spend all the energy. And I wonder if the correct response to AI is just go wild, use these tools, but responsibility, maybe it needs to go back to developers, so we'll see.
I suspect that is what we'll see. And as I said, that's not to say that AI is not going to solve real problems. I think AI will actually free the humans to focus more on those bigger picture things. I think AI is going to be able to take away the does this function do what it intends to do? Because it can understand that. It can tell us that. But I think it's going to be a tool and then saying, and so does this holistic change do what you want it to do?
Yeah. So speaking of change, one thing that I was really surprised that when I worked at Uber, I talked with other companies and stacking didn't really take off anywhere else because Phabricator was just not there. Why do you think that didn't take off? And how did you get the idea to start Graphite around this idea of, building this tooling to make it accessible for a lot more people?
Yeah, of course. Well, so I'll start by saying I actually don't think that stacking caught on inside Meta at the start.
Oh.
So originally when it was built into Mercurial. There were advertised at the company, there were a few senior engineers who saw the vision, felt blocked, and picked it up. And I think that, not in an exaggerating way, they saw themselves get 3x faster. And what happened was those senior engineers started to become evangelists. I had one on my team who was like the stacking evangelist. And they used to go throughout the organization and literally give PowerPoint presentations of like, this is how stacking speeds you up.
Wow.
Like, you need to believe me. I've seen the other side. And at the time, I think you had a lot of developers who were very skeptical, who were like, like, I've been doing Git for so long. Like, I don't need you to tell me how to change my workflow. Why would I do that?
I hear this all the time from current people who hear about stacking.
Yeah. And then like what ended up happening was that as these evangelists like made inroads and started to convince people like, no, it's actually speeding you up. People would adopt it, see the value, and like become that evangelist themselves. We like to joke that once you stack, you don't go back. I think why it works so well is it did two things really. It was like the perfect convergence of two forces. One is that it gave individuals what they want. So I think no developer likes being blocked, right? If you ask a developer, like, what is the feeling towards code review? Or towards having to wait on code review. It's almost always negative. No one's like, I love that feeling. Negative. People are like, it sucks. It's the worst part. And I think that even if you have a more senior developer that's had code review for 20 years, if you ask them like, why do you enjoy coding on personal projects as opposed to company projects? The overhead review of collaboration becomes quite clear there of like, yeah, because in like when I work with others, things just slow down. We need to review things. We need to align on them. They get a lot slower. And I think what stacking did is it took away some of that overhead, right? Where rather than having to wait on other people to review your code that you already thought was pretty good and you had already aligned on before, you could just keep going and keep building without needing to sort of wait for them. The second side is I guess it was great for three parties. The second side was the reviewer. The reviewers started to get smaller PRs, right? And whether you know it or not, when I send you a 10-line PR, you are so much happier than if I send you a 2,000-line PR.
Yeah, but like so many companies eventually, when they write down code review guidelines, they're always going to have small PRs. At Uber at some point we had like recommendations within the team for 50 or 70 lines, whatever that is. But you realize, I mean, there's jokes going around, and I think it goes viral on social media of the 5,000 line review looks good to me, and then the 10 line which gets like 10 comments.
Exactly right. And I think people, as we were saying before, people buy out of it. And the third is I think it really gave the company something they needed, which is that they started to see their engineering organization speed up. They started to see time to merge go down. That's usually a metric that people measure, and we can talk about engineering metrics separately. In the case that something went wrong, it made it much easier to correct things, right? In the case that QA or even users like found something that wasn't working the way it should be, it was much easier to then go to history and be like, which one of these changes did it? Than when the changes were like monolithic feature, monolithic feature, monolithic feature.
Yeah, now, you build this tooling and you are still a pretty small startup. How did you convince companies to use a pretty small startup, pretty unknown methodology? Rumors are Meta uses it a lot, because I assume it's not a really easy sell, is it?
No, it's not an easy sell at all. So back to the company's origins, I don't know if you know this, we didn't actually start as a code review company. So we actually started by building tools for mobile releases. That's the background of the founders. That's the area we wanted to like build in. I was fortunate enough to have two of my teammates from Meta join the team. And I think one of the things that the three of us felt was like, the tooling out here, I think they were both new grads when they had joined Meta, had been there for a handful of years, call it like 4. And then when they left, they had the same experience I did, which was like, the tooling's out here is different. And at the start, we kind of were like, we came from Meta, we must be the weird ones. And after about like a few months, we were like, no, like there's actually something missing here. And I think the context that I now have that I wish I had then was, one, most companies, if you have more than 50 people, you have at least one person who builds tooling on top of GitHub. And I think that if you've worked at one of these companies, you kind of just take that as a truth of like, yeah, I have the DevTools team, Dev Platform
or
team,
on top of Jenkins. But these days, Jenkins is GitHub Actions, so same difference.
Exactly. You have someone building tooling there to make your developers faster. The second thing is that these companies, so like Meta and Google, so GitHub released their pull request page back in 2013. They haven't really made a ton of major edits to it since. Those companies had their changes then and have continued to iterate on their tooling for like the past decade. And so when we say their tooling is like a decade more advanced, that's a quite literal statement, actually. That's not a figurative one. And so we realized that. We were like, hold on, like there's missing tooling out here. We tried a lot of the alternatives. As I said, stacking was sort of that first pain point. And so we tried a lot of the sort of like open source CLI first alternatives, realized it was it was like a approximation of what we wanted, but it wasn't quite it. And then we built it. And then what happened actually was a lot of our old coworkers, many of whom had gone on to startups, ended up asking us like, hey, like code review out here is different. Like, how do you all deal with it? And we're like, we built that. Let us know if you ever want us to tell you how to build it. And they're like, I don't, but like, can I just use your thing? And after we heard that for a few months, we ended up pivoting back in, I guess this would have been November of 2021.
Okay. So quick pivot in the beginning of so basically, did you just feel a pull? Like, okay, like this is a good idea. Seems like there's demand for it.
I don't think it was, the other company idea was working quite well. I think what we felt was we had all of our friends asking us for this thing that we had built, and it wasn't the thing that we were selling. And you can only listen to that for so long before you decide to say, maybe we got this one wrong. Maybe this is the thing.
It's just fascinating. I guess it's hard to appreciate if you're not working at a startup, because my imagination of joining a startup, I have friends, and my brother was working at a startup, but I didn't join a super early stage startup ever. Is you would imagine you're joining, this is what we're doing, this is what we're going to do, but sounds like you need to be flexible enough, because you might do something different that actually works and there's a bigger demand for it.
Yeah, we were fortunate enough that at the time that we pivoted, we were just 6 people. And so it was 6 people, and 3 of us had felt the pain from Facebook. So it was us telling people like, no, we've heard it. Like our coworkers have heard it. We'd gotten other people at the company to buy into this workflow at that point. And yeah, it was certainly stressful, but it was also a thing we just had enough conviction in. We were like, this is the way the world will build software. It's more a question of who's going to bring it into the world, not if.
So you previously mentioned engineering metrics. What are engineering metrics you see these fast-moving companies measure and actually care about and want to improve?
So I'll start with the statement that all engineering metrics are a proxy, right? So I think that measuring engineering velocity is an art, not a science. And I think that the value of engineering metrics is to create some holistic metrics so that you can see major outliers and be like, what's going on here? The kinds of metrics which I see most people measure are number of pull requests as just a proxy for sort of like how's velocity doing, time to merge of those pull requests, and then my favorite metric I've actually ever seen came out of Uber. And so maybe you might have more context on this than I, but it was basically time that a pull request is just spent waiting in review with no clear action. And so the idea was like, if an author puts up a pull request and is just waiting on review, you take that, then the reviewer goes ahead, requests changes, and like it's that you then ignore that time. You then put it back up for review, you start summing that time again, and you end up with this composite of like, this is the amount of time this pull request just sat waiting on review without clear next steps.
So this metric was introduced after I left Uber. I think I might have covered it in one of the deep dives on how Uber did it. But like this was a really big problem at Uber because we were distributed sites, and like my team specifically had this problem where we would have to wait almost 24 hours for something to happen on the pull request because we had strong code ownership, and I think Uber still might have it to this day. When I was there, we still had it. So the mobile platform team would own the platform code in San Francisco and Amsterdam. At last thing at night, you would make a change and you would have to head off. And it would go to them. They would reject it because of whatever reason. You come back in the morning. It's now nighttime in Amsterdam, in San Francisco. You fix it quickly, and then you have to wait another like 8 hours and then stay late. Yeah. So like I'm glad that they started to measure it and this is one of the things where it's not really a big deal if you're a startup, if you're in the same time zone, if you're in the same location, but and then, we came up with creative workarounds. Like we started to get, like, we onboarded someone to be an owner of it, etc. You can do a lot of things, but it was really killing us. Like, and I knew it because I was the manager of the team, and this was the number one complaint. So we actually, we took it into our hands and we solved it. But so many teams were doing this independently. And then it kind of goes back to, like, like as a dev, I didn't really like to hear too much about strategy, whatnot, but there is a thing of, like, who owns what, how do you place your teams? It's kind of easier when you have teams working on similar stuff close to each other in terms of time zone. So yeah. And, one other thing that Uber measured, which I'm not sure how successful it was, but it was an interesting thing, is they tried to measure focus time on how much uninterrupted focus blocks devs had. I think it's really noble. It's just really hard to measure, but it's true that when, like, I was always happier, like, developing when I actually had time. It wasn't fragmented with, like, the random meetings here or there, etc.
Yeah, totally. I mean, maker's schedule, manager's schedule is super real. I think that, as we were going back to before, though, these problems, which used to be more isolated to big companies, I think as we start to see a higher volume of pull requests and more of the time is spent sort of like in code review, not authoring pull requests, they're going to become everyone's problems. And I think the question is sort of like, how ready are companies for that change?
Yeah. I like this, thinking, because this will happen. So it's interesting how small companies might need to take some of the lessons from the larger companies on how they solve it and prepare for it, because it's going to come. Like, I'm kind of tempted to agree with you on this one. It'll be fascinating to see. It'll be also fascinating to see if small companies speed up a lot more than, let's say, big companies where there's larger teams and there's now more dependencies. It'll be an interesting one for us to...
I think small companies are certainly better positioned to embrace the change, where I think big companies will be slow. I think small companies, we've already seen them adopt a lot of AI tools faster. I think some of the, like, most advanced big companies are like just trying to adopt them at the same pace of these small companies, but they're definitely not trying to outperform them. And I think we've seen this actually in quite a few areas, right? Like, every time that you have a new technology that makes something more accessible, easier, the same way I think AI is making coding more accessible, easier, I think what ends up happening is that, like, practices that were previously only meant for, like, the tippity top of the market start to distill their way down to everyone.
So you're a co-founder of a DevTools company, and I think this is a little bit of a dream of a lot of engineers. I actually see this pattern pretty much as you join a company, you work on a product. If it's a big enough company, there's a platform team. A lot of engineers gravitate to there because you can solve pretty cool problems. In your case, you actually you were on a DevTools team, and then you find the courage or find the right people to actually start a startup. And what better thing to do as a dev, and what you already know how to do this, is build for other developers. What is something that you've kind of learned the hard way of starting a DevTools company? Because I assume it's a bit trickier than what you imagine. What was different than when you started out? Because it sounds like the dream, right? You kind of went out, you actually managed to raise some funding, and now you're going to build these cool tools for developers. And you're a developer, it's great. Your customer is wonderful.
I mean, a ton of things. I think that building a company can be very rewarding in a lot of ways. I think there are a lot of challenges. I think some of the things that you learn to deal with, some of the things I think we've learned to deal with here are sort of the diversity of engineering workflows across Silicon Valley and non-Silicon Valley style companies, right? Of, like, what does code review mean to them? What are they trying to get out of it? What's the purpose of it? And finding the middle road to blend all of those, needs, desires, etc., is difficult, is challenging, is something we build. I think one of the things that has most surprised me coming out of Facebook is what we talked around earlier, is the tooling. I think working within a company, you probably have that team that is building really awesome tooling, and, like, they really benefit from that. When you come out here into the wild, as I call it, a lot less of that exists, and you find yourself being like, okay, how can I set that up? How can I get back to that? A company which I'll give a shout out to is StatSig. So Facebook had really wonderful sort of like had really wonderful experimentation tooling, feature flagging tooling. And when I left immediately, not immediately, but like 6 months in, I was like, okay, cool. Like, we probably have our first like feature flag. Like, how do we go ahead and turn this on? And I think you just mentioned you're at Uber, you had wonderful tooling there too. There's all of this stuff that's set up for you that you just take for granted. And once you come out and have to build it, you have to start to be like, okay, how do we do this from scratch again? Or who can do this for me?
Awesome. So with that, let's wrap up with some rapid questions. I'll ask a question and you just shoot whatever comes to your mind.
Cool.
So first, what is a tool that you saw inside Facebook that is now outside Facebook as well, and that can be used and you think is pretty cool?
I think Statsig is still the answer I'm going to give here. It's very cool having the feature flag system as used to, and it's actually an amalgamation of a handful of different Facebook tools. Our feature flagging system, Gatekeeper, and then our experimentation feature, Deltoid. And so it's cool to see both of those, and QE2, I guess. It's kind of cool to see that sort of like reborn outside of Facebook.
That's awesome. And this is the beauty of like, I think, there was this like several years where DevTools startups got funded because I feel a lot of the things that were hidden inside these companies are now outside as well.
Totally. I think also one of the things that's, having worked at DevTools within Facebook and out of Facebook, I think one of the things that's so funny to me is that in Facebook, building DevTools is a lot easier. You don't need to worry about things like marketing. You don't need to worry about things like hiring. And I think it takes a lot of courage, and it's a very difficult path to build a tool outside of one of these large companies and say, no, I'm going to figure out how to make this work for the market. Because again, the engineering cultures are different. The constraints are different. The other tools you're integrating with are different. And so you have to start to rebuild all that.
And so what is your favorite programming language? Always an interesting
TypeScript,
question.
By far. Love Type. I think TypeScript is one of the most beautiful languages. And you're talking to a person that learned JavaScript when he was like 10. And then the type system on top of TypeScript, I think is really clean and does a great job with the constraints they have.
It was. I remember when TypeScript was created, and I remember there was a bit of skepticism around A, was Microsoft, B, do we even need this? Because the dynamic typing system is kind of like this wonderful thing that allows you to do so many crazy things. And yeah, like I think everyone has well, not everyone, but like most devs have slowly or surely seen the benefits of what we get, but with typing and with a nice language.
My controversial opinion is I'm glad Microsoft is the one to do it, because I think that Microsoft has some really wonderful compiler knowledge locked inside of it.
Yeah.
And I similarly had that skepticism. I remember at the time thinking like, we have Flow. What's the purpose of this? And I think that the formal grammars and proofs that they've done around it are really, really excellent. You can go really deep on group theory or category theory just by looking at TypeScript. I frequently look at other untyped languages. I'm looking at Ruby and I'm looking at Python, and I don't think they've gotten close to what TypeScript has done to JavaScript yet.
And then finally, what's a book that you read and would recommend? Fiction or nonfiction, 1 or 2 books?
So I am an avid mystery reader. So the mystery book I always recommend people is The Last Days of Night. It's a book around a Tesla, Edison, and Westinghouse and the race to invent the light bulb. It's written as historical fiction. I think it's phenomenal. As one who currently works in technology in New York, there isn't a better book I can recommend to anyone in that position. Nonfiction, I read a lot of books these days. I've been actually reading a lot more product books. The Timeless Way of Building is a really interesting book about architecture. The beginning is a little abstract to get through, but once you get to the sort of latter half, it talks around the importance of having the people who ultimately use tools or buildings be the ones who build those tools or buildings, because that's the only way that you create a self-sustaining cycle.
I guess it kind of resonates with developer tools.
Yeah.
Which seems kind of obvious, because who else would program the tools that we use than developers? It's one of these weird things, but yeah.
There's an MC Escher painting to be made about that.
Well, this was really interesting. I'm glad we were able to go a bit deeper into stacking than we previously touched on that article as well. And thank you for your time.
Cool. Of course. Thank you. This was always very fun.
Thanks a lot to Tomas for all these details on Meta's tooling, stack diffs, and on tooling trends. You can find Tomas on social media as listed in the show notes below. For more deep dives on tooling at Meta and more details on stack diffs, check out the Pragmatic Engineer deep dives linked in the show notes below. If you enjoy the podcast, please do subscribe on your favorite podcast platform and on YouTube. This helps more people discover the podcast. A special thank you if you leave a rating. Thanks, and see you in the next one.